right infrastructure choices today are more important than ever for a number of different reasons. So we talk about where data resides today, and today it's kind of all over the place. When we talk to the various labs, there's data lands on places from ingesting from your equipment, your microscopes and such. Sometimes the data needs to be moved and accessed via HPC clusters, AI clusters. And then at the end of the process, the data needs to be made available to your end clients, to end users for further processing of that data or whatever. And choosing the right place for that data couldn't be more important than ever. The days of being able to use USB sticks for your data are gone, right? We have things like NIST 800 standards that you need to comply with security practices. Data needs to be encrypted, secure, safe. If we're taking our images off the scopes with something like this, we go home and you plug them into a different computer. We have things like ransomware, which at the home, who cares? But let's bring that USB stick back and plug it into your data center today and watch the proliferation of a mess. And we all need to kind of stay out of that. And we're left with a lot of decisions to make by people that are supporting the infrastructure. They need to make sure that the data is available and accessible to you guys, accessible to equipment, accessible to HPC, accessible to different operating systems. One of the reasons why SBC chooses to work with VDURA is your data needs to be available and durable, right? So typically when we look at small shops, we see a lot of people spinning up their own instances of things like CFS. And the problem is small environments, yeah, it works great, but it doesn't extend, right? It's not available, it's not durable. What happens when components in the system fail? How do we make sure that our researchers, you guys, still have access to that data? So we need to be making sure that we're providing resilient, scalable, available data. The rate at which we need to access that data has scaled, right? We used to be on 1 gig networks, and we're looking at 100, 200, 400 gig Ethernet networks, and the ability to ingest data at phenomenal rates so that you guys can work with larger data sets, finish your workflows quicker, and move on to the next task. So all of that relates to, again, choosing the right platforms. And it's across the board. At VDURA, we use a supply the data landing platform. But you gotta make the right choices from a network perspective. We have a network that's secure, reliable, accessible. We gotta make the right choices from a compute perspective. Do we have enough cores? Do we have enough GPUs? How many people can this support? All of those things are super important today. So when we're making selections around infrastructure and data, specifically, we see a lot of different platforms in the environment. We see all flash solutions so that we can ingest data really quickly and work them into our workflows. But that's very expensive, so they're typically augmented with hard drives. And where do those hard drives exist? Sometimes today you guys will spin up instances in the cloud providers using like Amazon S3 or somewhere cheap just to land the data and accessible. But now you have a mix of how is it secured here, how is it accessible over there, how is it accessible to equipment people. How do we scale and grow that? We start small, terabytes of information now. Today we're ingesting petabytes of information. We want to continue to make it simple. Simple, reliable, extensible, scalable, and available. Those are the kind of tenets today that we see in storage environments. So as your environments are growing, for those of you who have smaller environments, or those of you who have large environments and are looking to kind of, how do we make this more efficient, safer, secure, accessible? You need to look at platforms that do multi-protocol. All through the workflow, things need to access data differently. So you have, as an example, your microscopes are typically run by Windows control stations. Those Windows control stations need to be able to communicate with your storage platforms via a specific protocol. And that's ingesting all the data that you guys are getting out of your science. That data is then typically moved over to something else because you're now analyzing that with GPUs or CPUs in a large HPC cluster. That's another protocol. Once that workflow is done, it's typically, again, pushed out to something like the cloud so that your end users can pick up the results of that. Further analytics can be done with that. But today, Platforms like VDURA, like we're offering today, are multi-protocol. You can access the same data sets with your Windows boxes, with your desktops at home, with your HPC clusters that are running Linux, with your really expensive NVIDIA B200 GPUs that are out there kind of consuming lots of power and lots of CPU space. So the platforms that you choose, again, super important. You want something that you can build and scale, whether you need all flash for the high performance needs, or you need cheap and deep, right? Places to land petabytes of data. The VDURA data platform gives our end users the ability to start on either end of that spectrum. Hey, today we're doing traditional HPC work. I don't need any flash drives. We can do it all on spinning disks. We'll build that out for you. Later on, you might come in and buy a super pod. I've got 256 GPUs that can ingest data at 18 gigabytes a second. We got flash on top of it. You can turn protocols on and off so that you can access all of those same data sets no matter how or what type of equipment you're using to access them. Again, desktops, you got your microscopy equipment, you've got your Linux HPC workstations, your NVIDIA DGXs. They all want to communicate in a different way. And now because the environment is consolidated, we've made it simple to manage. You don't have to have all those different tiers of storage for those workflows. Simple to manage, easy to use user interfaces, so you don't need expertise like you would traditionally use for legacy parallel file systems like Lustre. Right? And then you have a single place to secure your data. And what does security mean? A lot of different things. So are you trying to comply with NIST 800 standards? Data needs to be encrypted. We do encryption at the client level, right? So you can encrypt data sets that need to be encrypted. You can have data sets that are open that don't need to be encrypted. But an easy way to have a multi-tenant environment with access to high performance capacity that's scalable. Start from 100 terabytes, scales up to hundreds of petabytes or even exabytes of capacity, all with simple interfaces to your network. Single global namespace, and then integration with the tools that you guys are using in the workflows of your science experiments. So integration with things like Lotus to move data from here at NYSBC out to tertiary environments, which are done. We integrate with things like Starfish and Atempo for data replication, data archive, integration with things like cloud services. So really a single platform for anything that you guys need data related. Very customizable, very easy to deploy, very, very supportable. Any questions in the room so far? I talked about the flexibility of choice. And again, when it comes to storage, this is all about IOPS, gigabytes a second, how much capacity, and also budget, right? Also a very important target. And it's important, again, from that infrastructure selection, you guys pick as you're building out your environments or expanding your environments that can be customized to meet all of those different things: performance objectives, security objectives, access methodologies, and of course, the most important part of that is budget. What can we afford to put in that is going to meet our research needs? And again, from a VDURA perspective, we give our customers the ability to choose basically any platform, whether they want to go with dense hard drives, very cheap indeed. A 30 terabyte hard drive today costs about $500. Or all flash for those high performance needs, tens, hundreds of gigabytes per second. By comparison, a 30 terabyte SSD NVMe drive today costs about $5,000 to $6,000 depending upon the model, right? So 10x cost difference, and really being able to give you guys the choice to build for the right need is the best way to go, and you don't get that with all storage vendors today. What that means from an end result perspective is the ability to meet those objectives that you need, the ability to perform, the ability to make the data available. The back end of our data storage platform is an object store, so it's durable or erasure coding. You can lose components in the file system, right? Metadata directories, storage nodes, the piece of the file system, complete nodes can fail. Pull them out the file system and keep running. Right? That's very important to keeping So just a couple examples of other research institutions that are leveraging the VDURA platform wide. Obviously, NYSBC leverages our platform today. But Hormel Institute, so real-time ingesting of data. They were using legacy parallel file systems, things like Lustre. The problem was, as these things expanded, it required more expertise, more touch points, more integration with third-party tools, and we really just wanted to bring this in, have a single namespace, single data set to manage, and be able to do all of the protocols, access methodologies, and security that they were doing with various other solutions in the environment. Same thing with the University of Florida. They started very small, hundreds of terabytes of data, and over the years, their capacity requirements grew to petabytes. They needed a solution that was simple to grow, plug it in, the capacity is just there to use. No back-end manipulation or rebalancing of data. The system does everything that you'd expect it to do on its own. So that's pretty much what I had for you guys today. Any challenges from a data perspective in the room? Nope. All right. You can visit us at our table. I can go into more depth into the solutions that we offer today. Look forward to speaking.